Okay, so let's just start. So when we start, okay, so the purpose of how I approach this, I use Python primarily. I have very extensive experience working with Python, so I will start with this. Okay, so there are few inputs. If you remember in the question, let me quickly show. There are few inputs. One is like given an integer n, so that integer is, let's say, 8. I am taking it as a given. This thing is given. Okay, and okay, so that's the only thing which is given, nothing else. Okay, now let's so how can I explain you this part, because I also do not remember what I was doing there. Okay, but anyway, let's try to build it up. So the idea was that there is a list. So there is a list. Okay, and this list would be filled with the solution. So if you remember, like how our solution looks something like this. Okay, so if I have multiple of this, for example, I don't know how to copy and paste, so something like this. I think you got the idea. But yeah, probably the answer would be something like let me open it. 1, none, 1, 2, none, something. So like a total of 8, and like there would be solutions. Okay, so idea is like we will keep on appending our solutions to this list whenever we find a solution. Okay, and then we have I think that's all. Okay, so this is what we are given with, this is what we want to find, like this is what we want to append it. Okay, always like this is what we want to fill, and like later on this is something what we want to return or like give as an answer. Okay, that was the main yeah, that was the main idea behind the question, that you return all the distinct solutions. Okay, given, and this is what we want to find out. Okay, goal is to fill this solution list. Okay, let me help you in visualizing it. So solution would look like something, let's say in the first column I have kept, in the second row I have kept, in the third row I have kept, in the fourth row I have kept, let's say fourth, in the fifth row I have kept, in the sixth, in the seventh, in the eighth, something like this. And then let's say in the second position I have kept, in the first position I have kept, in the fifth position, the sixth position, in the fourth position, in the eighth position, in the seventh position. Okay, so this is how the once it is filled, this is how it will look like. Okay, means currently it is blank, as you guessed it. Okay, but later on we will write certain code here which will lead to this part, which means like if I print this solution, it will have those elements in it. Okay, so let's try. And now we try to now we are starting to approach the problem. Okay, so what we yeah, sorry for that. Yeah, so what we will do, we will create an empty board first. Okay, so if you know we have a chessboard. Okay, so first let's prepare the chessboard. So chessboard would be none multiplied by the number we are given with. What does it mean? It means it's the property of a list. If you multiply a list by a certain number, those element would be repeated. Okay, let me try to showcase print chessboard. Okay, let me start to show you. None. Okay, let me try to show you one more thing. If I have 1 plus 2 plus 3, if I have 4 plus something, if I do A plus B, now let's see, this is like, it's a concatenation, but it's not plusing, like adding it. Let's see this operation does not mean anything. Okay, so let's say if I do something like 1 2 3 A multiplied by 3, it will repeat the whatever is there in the, it will repeat the list n times. Okay, so 1 2 3 1 2 3 1 2 3. Okay, so now you get like what does this means. Okay, let me print it one more time just for your help. Okay, since logical till now. So this is the preparation part. Till now we know what we are given with, how we are going to return the result, like in what manner we are going to return the result, and how we are going to represent the chessboard. Okay, now let's try to build the solution path. So we have find all solutions, and we need to get the chessboard, and we are saying currently which column we are looking into, like we are looking for, okay, in the 0th column, means like the very first column, we have 8 queens which we want to place, and then I'm giving the list, or let me write it as all potential solutions. Okay, so this is better. Okay, so in a way this is I don't know, like I will do anything, and by doing this this list would be filled, and that's how I would be able to get the result. Like if I will print the solutions now, this should have the result, my results that I want. The problem is not the problem, but the very first thing is to understand how this is like, if I have a list over here, and I'm doing something with the list in this function, will it impact the above list? That's something we would like to check first. Okay, because that's the something which we are going to rely on, so we need to be aware. Okay, so let's make a small list, it has something in it, and let's make a function, let's say A, and I'm going to call it out. I'm giving the list, and then finally I'm printing the list, same list. Okay, now now let's say I gone here, and let me do something with the list. So I did what I can do, L dot append 10. Okay, later on I went ahead and appended 3 more times, and then I appended 11, then I appended 12. Okay, so catch is I'm not returning anything out of it. Okay, anything out of this function. Will my results show 10 10 10 11 12, or will it show like an empty list? Okay, so let's see this. So here you can see it really does modify the actual list. So this is specific phenomenon is like call by reference, in which I have a list which I was doing something with, and then I passed the list to another function. Okay, and then that another function did something to it, but ultimately that the list which I have passed is getting modified, is the same list I was working on. It's not a new list which he made by himself. Okay, like himself, like I meant the function here. Now, so this idea is clear. So anytime I'm working with a list and I pass the same list to a function, now whatever that function does with that list will be will be the final list itself. Okay, I hope this makes some level of sense. Okay, so that's exactly the thing what we are doing here. So we have a list, we are passing it to a function, and in return we are expecting that this list would be filled. Okay, let's try to now make this function find all solution. Here find all solution, and I want to do something. Okay, so I need to give the chessboard, I need to give which column I'm working on, I need to give what else. Just give me 1 second. Let's look at the full definition. Yeah, so I need to give how many queens I need to place, and then I need to give like the list on which I'm working. All okay, so these are certain inputs, and let's try to look at the solution. Okay, so in theory the approach is something like we will go column by column. Okay, means like okay, for us the iteration would be column by column. Means like if you know like how many rows we have, how many rows or how many column. A chessboard is a square, and we have equal number of rows and column. So the idea is we will go column by column. So this is a one column, this is second column, third column, fourth, fifth, sixth, seventh, eighth. Okay, so this is the idea. Like market has okay, so this is the column. Okay, the moment the column value becomes greater than n, what does it mean? So column value means let's say 8, and the column value becomes I'm not able to rotate it, but okay, the moment the column value becomes greater than 8, at that point of time whatever we have at that point of time we need to store it. That's what the solution will mean when I will explain it. Okay, now let's see the solution. Okay, and yeah, sorry, I forgot to mention, we are going to do this, we are going to our iteration is based on the column, second column, third column, fourth, fifth, sixth, seventh, eighth, and then in this uh, for when we are running for this column, then we are going ahead in this direction and trying to find out uh, the whether this is a valid position or not. Okay, this is a valid position or not can be answered by if this position is threatening other queens, okay, or like is being threatened by any other queens, okay, given the board. Okay, so that's something to keep in mind. For example, let's say I have kept my queen here. Okay, next time when I will be going to the another column, at that point of time when I will do the same thing, and now I cannot keep my queen here. And how you are going to remember this, like where you have previously kept. Okay, so that's something, a depth approach comes into the picture. Means like this is some sort of like a loop, a very uh, big loop which is going to happen. Okay, and for this we are going to rely on function calling itself. Okay, or recursion. I will talk about it. Just giving you very 1% overview, or like how I'm going to see. Once a queen is placed, the moment a queen is placed in a column, we go to the next column and we are going to approach, like, can I keep my queen here? No. Can I keep my queen here? No. Can I keep my queen here? Like, yes or no. Okay, so this is the answer yes or no is going to be given by another function which I will again talk about. But the moment I get this, I get the yes for like keeping my queen here, I can go to the next one. Okay, so now let's see this in action. Okay, so first thing, if column like in which I have to place the queen has become greater than how many queens I have to keep. So how many queens I have to keep means, like, if you remember, I had to keep initially 8 queens. Okay, so whatever is here, okay, it does not matter, it would be uh, like always keep on changing. But let's see, if the column value has become greater than n, what I have to do, I have to let me this, I have to add whatever is currently the board. Okay, means like whatever I have, like, whatever the board configuration I have currently, add it to the solution. Okay, so what does it mean? Let's say I was playing the chess here and there. Okay, I was keeping my chess here, whatever. Okay, and so this is some sort of a breaking statement. Okay, now let's say I have my 9th column, I can go, let's say my function is not limited by based on if you remember, in C we have like a for loop and other loops also, but in for loop we have to tell the when I want to like stop before even starting. Okay, but in other loops, in the do while loop or while loop, you have to you don't need to know that answer. Okay, that's something the same. So though we wanted to go with a fixed number of what we say the iteration, but this question is very dynamic in nature. So having a fixed number of like times for which we can do the loop was like is not a correct answer for this. So that's why first we want to go with the while loop kind of approach. Okay, and for that the main intention was like we know when to stop, but we don't know how many times we want to do. Okay, so that's something keep in mind. With this statement only you will know when to use recursion. Okay, so recursion or like while loop means like you will know sorry you will know when to stop, but you don't know how many times you want to do certain thing. Okay, so you know in this scenario any times I go beyond 8, at that time I need to stop. Okay, this time the loop will go for 9, but I know for 9 I don't need to do anything. So now whatever is the board configuration I have this particular scenario, I will add to the solutions. Okay, so this is my solutions. Let's say something like this is going to be a bigger list. Okay, so this is one of my solution. Okay, and let me have comma, let me make a comma also here. Okay, so this is one solution. Okay, similarly we will go ahead, I will show you. Okay, so that's what this statement mean. Okay, whenever column value goes beyond how many, like the numbers of queens we wanted it to place, do one thing, store that board configuration into a solution. That's all. Second part, now given a responsibility to find out now let me tell you how why does code look like this. Okay, for example let's say I can give you the same question by just can I give you the same question with initial board configuration as this? The answer is yes. Okay, can I give you the same question with, let's say, the initial configuration as this? Same question, but I will say instead of this use this as an initial configuration, this board. Answer is yes. Okay, now let's say if I give you this as a question, and so which column I will ask you to fill now? I will ask you to fill the 5th column. Okay, let me add one more thing just to, let's consider this as me as a wrong, but let's, yeah. So if I give you this question, I will ask you fill the 6th column. If I will give you this board, I will ask you fill the 5th column. Okay, so that's the same thing. Sorry, like I have some bit of cold and cough, like I'm not sure like how many days it will take to get correct, but I'm just trying to make some incremental efforts to be slightly to be slightly more consistent in what I'm doing. So that's where like I I just wanted to make some incremental effort. Okay, so I explained you that initial board configuration can be anything, which means let's say now for row in range n, it means like 0 1 2 3 4 5 6 7. Okay, so this loop is 0 1 2 3 4 5 6 7. Okay, then I need to ask, let me copy this because it's a long thing, but it's a self-explanatory word. I'm going to implement this, but let me okay. But if you see now, if this queen placement which I'm going to place non-threatening to other, this question I need to ask for every position. Okay, and anytime I get no, I don't need to do anything. Okay, is this queen placement correct? Now to answer this, I need to give the chessboard configuration. What's my chessboard currently look like, and then where I want to keep the like so it means, so let's say I'm given with the chessboard. Okay, and the question says in the sixth column and in the B, let's say in this this is the seventh in sixth column, seventh row, can I place a queen? So it means that. Okay, if I keep my queen here, can I keep it here or not? So that's the crux of it. Okay, now is this queen placement correct? Means like I already know the column in which I was asked to keep the okay, I think I should have made a better one if I go and have given like the chessboard. Okay, column in which I have to, and then the row. Okay, I think this would make more better because our point of reference is like column and then row. Yeah, okay, so I can ask this function by giving a board and in which column and in which row I want to place, by telling it which column and in which row I want to place and in return it will give me the answer, can you keep the queen there? If it says no, then I don't need to do anything. If it says yes, then what I do in that chessboard, where is that, in that chessboard, in that particular column, I can in that particular row I can place I can place a queen. This means that. Okay. Now again, so once I have placed let's say a queen here, let's say this was the question. Next thing what I'm going to do is, next thing I'm going ahead and I'm recalling this. So I'm saying go ahead and find all solution again for this chessboard. Okay, so whatever the chessboard I have, means like till this one, till this chessboard, I'm giving a copy of this chessboard. Okay, let's suppose I have given a copy of this chessboard. Okay, and now okay, so last time I placed this one, now I want to place again queen now to the seventh one. Okay, so seventh means like till wherever I have done. Now in the next column again, n would be the same, like number of queens I want to place, and the all potential solution will be the same. Okay, so anytime it will find a solution, it will give that. Okay, after it, what I'm doing, like that's the something the most crucial part. So let's say I was able to now that's something that would be slightly challenging for me to explain, because it is I also do not remember at this moment what was it doing. Okay, but I know the direction in which I know the direction way to look out for. Okay, so the problem was, let's say if I am able to place my queen here, and let's say now same thing happened, and now I have to place a queen. Okay, now problem is, let's say I went to this, I'm not able to place the queen. So what will happen? Where is that? Yeah, so what will happen? The let me show you. Okay, okay, so this will repeat again and again, and then finally it went ahead to this. Okay, let's say, and this, but it was not able to place the queen anywhere. Okay, for every iteration in the last board it says no, 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 no. Then what will happen if all of this is no? Then what needs to be returned? Then you need to say false. Okay, so this might be a wrong solution, so probably I should have said false. Okay, in that scenario it will say return false. Okay, now if something is returned false here, means like if something is returned false, so think of what will happen with the previous queen placement. Previous queen placement means like whatever was the previous board configuration, what will happen with that? Last time what I had did, like I was able to place my queen here, and now it returned, this also returned false. If this returned false, it means this function returned false, correct? No, like ultimately, like the true can only be returned from here. Let's say if I forgot to mention here, but if this return false, ultimately this function return false. So it does not matter where you have kept the chess, what you have kept in the chessboard, but this return false. It means what happens to this? It also return false. Nothing can be done. Go back, go back, go back, and go back. Okay, like again, like if every combination was false. Okay, if this return false, this return false, I think this is not a proper, because I also getting some better approach I think I can get to explain this. Okay, let me try. Let me, I can keep my queen here, I can keep my queen here, 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 yeah, here, yeah. What is happening? Then can I keep no, 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 no? Is it no? Yeah, no, I cannot keep my queen here. Can I keep my queen here? No. Okay, so if you see in this configuration I was not able to keep my queen here. Okay, so what will happen now? This function will say, okay, till now what's the board configuration is? Board configuration is, let me show you, in first, in third, 1 2 3 4 5, then in the seventh, in the second, in the fourth, in the sixth. Okay, till now this was the board configuration and one point was remaining. Okay, this was the board configuration, and then this function returned me none. For this particular board configuration, I was not able to place one more queen. Okay, now what can be done? So what I will do here, then I did what? I did one thing. I took the chessboard and that particular column, this particular column, and mark it as none. What this means, if this function returned me none, it means I was not able to keep the chess, keep the queen here. Okay, so it means none. Okay, if it is none, then what will happen? What I'm going to do with this? Am I doing anything with this? No, nothing. So think of it as you are only taking the positive scenarios. How can I explain you this? Means like, let's say someone is giving you some advice, and whenever they give wrong advice, you just ignore it. Okay, so that's something it means here. If okay, let's also get the another scenario. Okay, let's say this position was also correct. Okay, then what would happen? It would be in the 8th position it is. Okay, now what I will need to do, I would have need to go here. Okay, so this function would call the next function, which means like do one thing, go ahead and like try to fill the next column. Okay, but the moment we try to fill the next column, then what will happen? It will come here, it will see, oh no, the column is now greater than the number of queens we want to place. Okay, so again I tried to show you with this dot, but ultimately the list was like, the board configuration was this at that point of time. Okay, if this is a valid condition, only in that scenario we will go ahead and we will say, yeah, our chessboard is fine. Okay, yeah, I know it's really a complicated question, but this is how I will talk about this again. Don't worry, I will try to brief it again and again till the time you get the essence of it, because I know it's really challenging, but there are 4 or 5 things which is fundamentally we are doing, why we are choosing to do this way. That is something which is important to understand, because this question is nothing like you are just looking at the solution, but I don't want you to understand the solution, but the why it is being done this way. That's something I want you to understand. Okay, now let's implement the last part of it, which is how to get this part. Okay, given that given you have a board, and now a person comes in is saying that to place the queen in this column, and then in this row, in this column, in this row, how I'm going to validate if that is a correct position or not. Okay, let's go add and implement it. Okay, now for one more thing I forgot to say. So if you know that when I was reading the my own code, I was not able to get it in the first time. Okay, so what I will do again, so that I would be able to understand it next time, is that I will write it in a language which is very human friendly. Okay, I will rewrite the function names and parameters, so that it becomes easier for you to understand and easier for me to understand also. Because like anytime I see a code which I'm not understanding, I blame to the other person that you have not written it well, that's why I'm not able to understand it. Okay, so that's the crux, the summary. If you are not able to understand this code, it's on me, not on you. Okay, because it's, as a writer, it's my duty to explain you this, if you are here for that. Okay, now let's try to understand this question. Like this particular portion of the problem is given chessboard, any chessboard, whether it can be, let's say, this chessboard or this chessboard, and given some like row and column, that where we want to, I need to tell is that is it something valid or not. Okay, now what we are going to do here is there are okay, let's try. Okay, so what is this? For existing column in range, it's a very bad name but let's see. Okay, for column in this, now how can I explain you this is something what I'm thinking. Okay, let me try to explain you. So let's say don't worry, I will be able to explain. Okay, so this is the board configuration and I want to place my queen here. Okay, so this is the question which I have given to the is this and like the responsibility of that function is to tell me whether I can place yes or no. Can I place yes? Can I place no? That's something. Okay, now what we are going to do in the code. Okay, so in the code where I want to place in the 7th column. Okay, in the 7th column, so what I'm going to do, I'm going to first, like I will do a small iteration, and then I will and how many times I will do till this column, till here 6th column. Okay, first column 6th, I will going to check in 3rd, then 4th, then 5th, then 6th. Okay, from like just of one column before, like till this column I'm going to check. Okay, what I'm going to check now, 3 things I'm going to check. So let me write first here. I am going to okay, so there would be a loop required for how much, let's say for okay, if I have 7 here, the value is 7, and if I do, let's say, the range to 7, what will happen? It will run from 0 1 2 3 4 5 6, right? Okay, let's say for I in let's keep like this. Okay, I am going to check 3 condition. If there is a queen, in this column, okay, I'm checking it for the very first column. If there is a queen in this column, if there is a queen, I can say, let's say, how I know there is a queen or not. If chessboard, like, and let's say any row, okay, if you remember, let me tell you that also. How was our queen represented? Sorry, how was our chessboard represented? 2 none, 3 none, something none, or 2 3 4 something. This is how our chessboard was represented. And let me do a none here. Okay, like just by looking at it, yeah, there is a queen in this column. Okay, when will queen will not be there? When the when like there is some not none here. Okay, so how will queen? I will check if chessboard particular I value, let's say, is not none, something in this direction. Okay, I identify if there is a queen or not, and then I'm going to do something out of it. Okay, once there is a queen, and then I will check if this lies on the same row or same column. First I will check this, and then let me show you how it is happening. Okay, so first is queen is in this row. Okay, so first, okay, so let me write it better for previous call. How can I write? Let me write it as C. Okay, now queen, let's say already let me write it out for the timing. Queen is in this row. I know that can be checked by a board, and then the particular column value, in which column I want to check it. Okay, that was chessboard. Okay, then if that's also not a good name. If queen is in this row, like if a queen is not there in a particular column, then I will have a none there. Okay, if queen is not there, then don't even bother and go ahead and check the next column. What is mean? If a queen is not here in, let me represent it. 1 4 5 3 2 1 2 3 4 5, and then yeah, this was the board configuration. Okay, and if there is none here, but let's say the queen was not here. Let's say the queen is not here, and that is represented as none. Okay, let's say if the queen is not here in this, I check the very first index, and then queen is not present, then I don't need to do anything. I don't need to check any condition, okay, against anything. I move ahead to the next part. Now, like once I've checked, once queen is there, then I need to do what? I need to see is equal to row. What does it mean? Let me try to explain. Queen is in this row. So when I say fourth, okay, it means, let's say 1 2 3 4. So queen, if you look at this configuration and you see 4, it means in the second column the queen is in fourth row. Okay, let's say you were also told to place the queen in this row. Will that be valid or not? Okay, so immediately you will know the row in which if I was asked to place the queen is the row in which a queen is already there, so you cannot do it in the same row, in the same column, you cannot do it. So that's the same thing we are checking here. If the queen is in the row in which, like where I have been asked to place the queen, return false, you cannot keep it. Okay, then this is a diagonal testing. Diagonal testing means okay, so it's sort of let me try to write it out and then I will explain. Okay, now so how can I explain you this? Let's, the idea is if any, let's say I was on this row and the queen was here. Okay, I need to know whether my queen, where I want to keep the queen, is intersecting with the currently the column for which I'm checking. Okay, so how can I check this? Let's try to find out the row and column. Okay, so what's the row and column for this? Row is, let me write it. Row is sorry, the column is 2 and the row is 3. Okay, column and row. Let me write it for where I want to place. The column is 7 and the row is 8th. Okay, now look at this formula. So it says like if you subtract the rows and if you subtract the column, they would be equal if they are on the diagonal. Okay, so let me subtract the column, which is 5. So it's very common, like it's just a pattern, probably you need to find out. But if I subtract the column, let's see the column part, column is like 7 to 5 remaining. If I subtract the row part, they will also be 5. Okay, as long as 2 cells after subtracting the column and rows, they would be on the same diagonal. That's what mathematics says, and that's what it means here. So this will also check if the queen is on the same diagonal. Okay, and if all of these, any of the condition did not was not able to fulfill, then at the end we will say, yeah, that's a true condition. Okay, now let's try to look at the solution and let's draw it. So we have got the solution, so that's the solution. Okay, so now let me give you a last 1 to 2 minutes, not on the question but on where we are standing. Okay, so if I make a progress bar for the solution of this question, I would say let's say this is the whole, okay, let's say this is 0%, this is 100%. For this question we are something till probably around here. Okay, we are till here. So till now we are able to solve it, but there are a lot of things which we need to know before we can say like, yeah, we know the solution of this question. Okay, just keep in mind, and probably at least at this point of time you would be able to understand the approach. Okay, again, it's very vague at this moment, but I know we would be able to do it, and I have full belief on my abilities to explain it, though I'm uh, very naive in this domain, but I have confidence on my explaining. Just keep just be with me, and ultimately you will have the good understanding, or at least my uh, how I approach things. Okay, so till now we are here, and there is a uh, huge area which we have not covered yet. But yeah, one thing, let me clarify one thing. So after doing this question, you would be able to do almost every backtracking or recursion problem. That's the guarantee which I will give you. Okay, because I'm not I have chosen this problem because it's one of the hardest question, and it has a lot of story behind it. Okay, that's the reason I find this question very interesting, because the direction in which this question is being solved, that's a very beautiful. Okay, and if you are able to solve this, I think most of the backtracking, recursion, and every other problem, you will know when to use that. Okay, so thank you so much for, if you're following till here. I would recommend. Okay, anyway, it's your choice how you want to go with it, but that's something I'm trying to do. Wish you a very nice day. Thank you so much for watching till